Yeah, he told me like I have eggs.
The second part for C programming for hackers, and let me share my screen. Okay, am I audible?
There are.
Okay, so today we are going to cover two things. First is working with arrays. What are arrays? How to use arrays? How to initialize those arrays? Working with character arrays and working with the strings a little bit. Then fixed length arrays and variable length arrays. And at the end of the arrays session, we will be looking at what are the dangers of incorrect handling of arrays, to be honest, right? So after that, we are going to cover almost everything about functions, like what functions are, how they work, then how they handle arguments and local variables, how to return values, how to process data, introduction to a top-down programming approach, then how to use functions and arrays together, and we will be looking at what recursion is, right? So before that, did someone solve the questions that I gave in the last session? I gave two questions as a homework. So did you solve anything, or did no one solve it? Okay, so क्या समझ नहीं आया था? Should I unmute you? Okay, so I'm unmuting you, and you tell what was thing that you did not understand. Okay. Just a second. Okay, so you did not get the -10 input and output 248. Yeah, so the first question you mean. So let's start with solving that first question, right? So Sublime one notes. Let's close without saving. Q one dot C. Okay, so this is, we are going to write a little program to demonstrate what the output was, as well as we will start a new tab to understand why the answer was minus. Oh, sorry. At -10, the output was 248. So data types is something we discussed last time. A place, it defines a fixed size of data and operations permitted on data, right? So these are the two things that a data type defines. Now a char is 1 byte, which is 8 bits. And therefore the least value that it can hold is and the max value, right? Max value. So it can hold two values. I mean, it can hold multiple values. The least would be when all the bits are 0, and the max would be when all the bits are 1. So that let's represent every single bit. So 1, 2, 3, 4, 5, 6, 7, 8. And the max value would be 1, 2, 3, 4, 5, 6, 7, 8. So these are going to be least and max values if we are talking about the unsigned part, because uh, unsigned is what we are working with. Now, since unsigned is everything is positive, there is no negative, and therefore this would be 0. And let's just put it in perspective. This is 0 and this is 255, which is 2 raised to power 8 minus 1, right? Now what happens is, let's suppose you have unsigned char. Okay, so let's suppose you have an unsigned char. Let's just code it, right? So I will explain there. Now, unsigned char number, let's just set it to 0. %u is to print unsigned numbers. So we are going to print an unsigned number, and since it is going to be a single byte, so we are using %hh then u to just print the byte. So this will print 0. Now what happens if I subtract 1 from it? Anyone would like to tell what would happen if I do this? Actually, before that, let's just do it this way. 255, and we are going to print it 255, and I'm going to add 1 to it. Now equals to num plus 1. And we are again going to print it. So let's just compile it. So we get an output which is 0, 255, and 0 again. But 255 plus 1 should not be 0, right? Now the reason for that is, since we have only 8 bits to represent, and this is 255. This is 255. Now if we add 1 to it, right? Let's just add 1 to it. What we get is, of course, the answer is 256, but it requires 9 bits to. It requires 9 bits to represent. So, but we do not have 9 bits because character is a char is only 1 byte or only 8 bits. So what happens is, when you put something which is more than it can handle. For example, the result is 9 bits, but what you have is only 8 bits to represent. So it will take the lowest 8 bits. And therefore the answer is 0 in this case, right? Num plus 1 should be 256, but the answer is 0. And this thing extends because, see, what happens is, when we try to do the reverse part, so let's suppose we have 0 and we do a -1. Of course, that would result -1. So, but that -1 is again in terms of 2's complement would be represented as all bits set to 1, where this bit says that it is a signed number, and The rest is, at the end of the day, this is -1 in 2's complement system. So if you add +1 to it, which effectively should be, I would say, -1 + 1, and which should be 0, the answer is 0. And we saw it, what happens when we add 1 to it, which is the last 8 bits are 0. And since a character only handles 8 bits of data, so the answer is 0. This thing extends because let me show it to you. Now num equals to 0 minus 1. Okay, let's just do it again. Num equals to 0 and num minus minus. You see 0 minus 1 is again 255. And the answer is, the result is all bits set to 1. But since we are interpreting the result as a positive number, as an unsigned number here, so we are telling it to not look at it as we are asking it to not look at it as a negative number, but rather take it as a positive number. So when we remove the sign, we get 8 bits to represent a positive number, and that is why we get 255. So similarly, if you do 0 minus 10, it will go to 10 positions before, and therefore it will provide 248 if I'm not wrong. So num equals to num minus 10. 246, sorry, because the negative number that starts with is okay. So the range is again -1 to 9. So when we take the signed part, if we remove the unsigned, it will give us the right number. Not right, I mean, yeah, of course this is also right because we are still interpreting the negative and positive. So unsigned forces us to see the number as a positive number. So is that clear? Now what this is said is, this is I think don't really remember the exact term, but this is boundary wrap or something, right? So the correct term is something I forgot what they exactly call it, but this is boundary wrap. So what happens is, as we demonstrated, when you reach the boundary and add something, it then goes to the increment or decrement at boundary condition, and you get to the least value or most value, most value. So I think that is clear. Anyone have any questions about this? Okay, great. Now, someone asked me a question, and which was very, I would say, interesting when you look through the lens of this wrapping part, right? So I received a question. We have an unsigned int j, and j equals to unsigned int 50 plus unsigned int, sorry, not the unsigned int, unsigned char minus 10, and we get an unsigned int 50 again. So the answer to this would be 346, right? And the answer would be 346 because let's just put a comment here. And this is 50 because it is an unsigned number. Minus 10 is 246, right? 246, and we again have 50, which is 346, right? But what happens is if I change it unsigned char to unsigned int, now the answer is 90. But how does that work? So what happens in this scenario is unsigned char was, since unsigned char has a limited value, so minus 10 got 246. But an integer, the range of an integer is, in case of an unsigned value, the range is 0 to 2 raised to power 32 minus 1. Now what happens is, as we saw in the case of minus 10 on an unsigned char, the same happens with minus 10 on unsigned int, which is 2 raised to power 32 minus 1 minus 10. Not minus 1, but yeah. So it goes that way. And it is a positive number. So this ultimately yields something like this, which if you break it again, for example, 2 raised to power 32 minus 10 plus 10 plus 40 plus 50, which is essentially what it is, right? 50 plus 50 plus 2 raised to power 32 minus 10. And this will eventually be, this part is again going to get zeroed out because this will, reach again to the boundary part, and then we are left with 40 plus 50, and therefore the answer is 90. Now these are just boundary result conditions, and this is just, it is, right? So any questions? Everything that you're seeing here is because we have a limited number of bytes to represent things, or limited number of bits to represent. And of course, if something overflows, if you can, if the result is 33 bits or 34 bits, but you have an integer which only stores 32 bits, you are going to be left with only the lowermost 32 bits, right? So now with that, we all covered the question. Let's move to arrays. So what an array is? An array is, not this, yeah. An array is a continuous space in memory. And consider the situation where you have to store similar data multiple times. For example, let's suppose you have to store marks of 50 students, which is one of the most classic examples that is given, right? So 50 students, marks of 50 students, or of 100 students. Or let's suppose you want to make it, I would say, dynamic, and then you ask the user how many students there are, or how many values there are that you want to store, and you want to perform some operation on that thing. So a large collection of data, a large collection of data, and you need some operation to be performed on this. Now, one thing that you can do is you can define so many variables, but that would be counterproductive. You of course cannot define 50, 100, or 2000 variables, name them properly, and then use them as they are required. Or the second thing is to collectively place them in such a way that they can be accessed serially, right? And by serially, I mean which simply translates to they can be accessed in such a way that base element, nth element, let's say the nth element is base element plus n or n into x or whatever, right? The point is you can directly access the nth element. So what this provides you with is a flexible solution which you can apply thoroughly. Why? Because it does not matter you have 20 elements or 200 elements or 2000 elements or basically any other number which you can work with, because you can always take the base elements address and then you can move ahead that many number of bits, bytes, or some combination of bits or bytes which are going to be dependent on the number of element, which element you want to access, and kind of in this way, and you get that element, right? So this is why arrays provide a very simple solution to the problem that you have a lot of data points or a lot of different things which you cannot just define every single time when you want to use them. So let's create something. Let's write an set of function to demonstrate our point, right? Let's write something. Okay, so let's just define the objective here to demonstrate that. Let's say the purpose is to generate 100 random numbers and get an okay, let's just have it to get the average of 100 numbers where each number is between 0 and 10, 0 and 9 inclusive, right? So to solve this, of course, I'm not going to enter all the numbers by myself. 100 numbers, 100 is a little big of a number. So what I'm going to do is generate 100 random numbers. So let's just include a standard library.h. I believe we can. Let's just, okay, so first have a look where the number is. Okay, it is in standard library and it is a pseudo random number generator. So it just returns a pseudo random number generator in the 0 to rand max, that is mathematical range. So let's now the syntax is very simple. Each array is, okay, let's talk about the syntax part. Syntax. each array needs to be of a specific type, and it is declared similarly the way we declare variables. For example, if it is an int x, so int type array, the difference comes in we put square brackets and tell the size of how many elements are there are going to be. So 100 would say there are 100 elements, and here we are saying that array has 100 element. Array has the space of 100 elements which are integer type. So therefore the total memory used by the array would be 400 bytes, because as we already saw in the last session, int takes 4 bytes on this machine. Now let's run a for loop 0 to 99 or 0 to less than 100, which is actually 100 times, and array I, and we access the ith element or this element, right? We can say ith element is at, so for example, I want to access 10th element. So 10th element is going to be 9, because this is the 10th element, and nth element is going to be x n minus 1, because the way array is organized is the indexing, or the array index starts at 0. So do you understand why array indexes start at 0 and not at 1? Because if they start at 1, we have more flexibility, because you do not need to subtract 1, which sometimes or many times brings confusion. So till someone answers that, let's just write the code for this. Let's initialize the random number generator. And let's see what we have generated. We can actually do that instead of writing another loop. Okay, it requires a number, which is this, does not matter, minus O array. And as you can see, we get some random numbers, right? So let's just, instead of 0 to 9, let's say 0 to 99 or triple 99, right? So, oh yeah, compare it again. And now these are the 100 numbers that have been randomly generated. So we get some random number generation. Now let's set something which is unsigned int sum, because average would be sum of all the numbers divided by the total number of numbers, which we are setting it to 0. And instead of writing another loop, let's just sum is equals to sum plus array I, right? So we have already done that. Printf, and to now the number, the average can be having the average can be a number which is a decimal number, I mean a real number, or it can be an integer. So to go with the flow, we would say it float. float average equals to 0 again, and here we are going to set it as average as sum divided by 100, because that is the number of elements we have in this thing. %f to display float, and we also need a new line. So there we go. The average is 476.0. The average is 476. Okay. Yeah, so the answer is going to be 476 because I have provided a fixed seed here. And let's make it truly random. I mean, as random as it can be. So to do that, we are going to include time.h, hash include time.h, and we're going to pass time null as the parameter, gcc array.h, yep, array 531, 523, 484, 495, 449, 519, 517. So this is, if you can see, this time our average is changing, but last time our average was not changing. The reason for that is this time we have provided a seed, which is the null value to the time function. And let's see what that does is, okay. I need to see it on the, yeah, there it is. Time returns the time as of number of seconds since the epoch. So every time this this is executed, since the number of seconds have changed, because we are ahead in time since the last time of execution of our program, the seed changes to sred, and therefore this random number generates a different random number. So this is one of the applications, and this is how you can manage. So consider there were 1,000 numbers, right? Let's just put 1,000 numbers here, and let's change the loop from 100 to 1,000, and let's again divide that number by 1,000, and compile it again, run it, and you see we did not need to create 1,000 variables to manage every single, or to take input, or to process a number, which is, we are, in this case we generate via random number generation, but it can be taken as an input from a file, or it can be asked by the user. Of course, someone has to do the work. In some cases, no one is going to enter 1,000 numbers, but let's suppose for some reason you need to enter it, right? So this is how you can effectively access any element, provided you can pass it a correct index, and therefore it does not matter what is the size of the array as long as you can access it. So coming back to the question, why the array indexing starts at 0 and not at 1, the answer is the array is represented in memory as, let's suppose we have, let's talk about this array, right? So let's talk about this array. So it has 100 elements, and every element has its own memory address. Now the first element, let's suppose the first element is at 0x100. Now since array is a continuous space in memory, and it is an array of integers, so the next element is going to be 0x104, because each element is 4 bytes in size. Next element is 0x108, 0x10c, 0x10, oh sorry, 110. So this is how the element addressing looks like, and we can verify that by printing the addresses. But yeah, so and since the array starts at this address, which is this, yeah. So this is the address part. Now, how this expands, for example, x. Sorry. Now to see how this expands, xi expands as xi is simply x plus size of data type into I and dereference that way. And this might look complicated to you because you have not still seen the pointers part, but in terms of pointer representation, it looks like this, where x is the address or the base address, which is 0x100 in this scenario, and the sense size of data type, it depends upon data type, since we mentioned the data type, or else it would not know uh, whether it is a character or it is an integer, right? What is the size? So size of data type and I. To verify this, let's just make the array 10 elements long, so that it does not just print too many times on the screen. And let's just print value. Okay, let's just have it array. %p contains value. And to take the address of variable, what we have is to have or to obtain the address of this element or this local variable inside memory, we put an ampersand before it, and this gives us the address of this array. So let's just yeah. Okay. I also need to print it on the next line. Okay, so I had three things. So the first thing is also I. Yeah, so this is, there we go. So 0th element is at B0, 7B0, first element 7B4, second element 7B8, then 7BC, then C0, C4, C8, CC, D0. Now, if you notice, every element or the address of the next element is 4 greater than the address of previous element. And this is because the size of an integer is 4 bytes, and you can access ith element on an array by this notation, which effectively expands to this. Now we will be talking about this interpretation or this representation in the session about pointers and pointer handling. Okay, so is that clear how what arrays are, how they are accessed, how they are used, and how they are represented in memory? Or are there any questions? Okay, it seems there are no questions. Great. So that was the easy part. What take values in the arrays? Yes. So now we are moving to two things. The last two topics of the arrays. First thing, yeah. Okay, we have three things as well. Character arrays, strings, variable length arrays. Okay, spelling is wrong, but yeah. Dangers of incorrect array usage. Okay, cool. So let's talk about how we take input as uh, strings, right? So strings, not C. what we have seen in other languages, usually strings are something that are inside double quotes and a collection of um, characters which are tied together, kind of, right? If we talk about the easiest or the simplest definition, that is a string is a collection of characters that are tied together. Basically, you can say in terms of an array, right? So where uh, let's suppose the string is Himanshu, and in most cases or in most languages you can access individual elements of the string, which would be string 0 would be uh, h, or in some cases h, sorry, yeah, a string 1 would be I or I. Now there is a distinction between the two things, right? So the distinction between double quotes and a single quotes. C has a distinction between double quotation and single quotation. Python does not have a distinction between single quotation and double quotation. C++ also has a distinction between single quotes and double quotes. What is the distinction? Now single quotes in C represent a single character. A double quotation is represented as a string. But a string is not an array, or I would say a string is not an array of characters. These are two different things in C. So now the question is why, right? How are these two things different? And let's first start with something taking input as a string. So to define a name or to store a name, which is going to be a collection of characters, we need a character array to store it. So let's write a program which simply takes your name and put a name and count letters in it. Now, second part can be done with the help of a function present inside a library or a header file known as string.h, which is pretty simple, to be honest, right? So starting with this, let's define char name max 100 bytes, right? Who knows? So printf enter your name scanf. Now to take the input as a string, we pass %s and the name of the array. And let's count. Yeah. Unsigned int size. So size is equals to string length, strlen, and name. Printf hello %s and your name contains %u letters, right? Makes sense. Name and size. GCC strings.c minus o strings. My name contains 8 letters. Now to do, okay, so we have done this. Let's access the string as a, now since this is a character array and not a string, so that there's a difference between the two. To first show you why this, how it can access it as a as an array, let's apply a rotation cipher, right? Which, if you are familiar with Caesar cipher, which Caesar cipher adds 13 to each or moves every character 13 places next, or 13 places further, we are adding 1 to it, right? So move every character next, or 1 in line, whatever, right? So let's run the loop, and from 0 to size, because we have already determined how many characters are there, and then we are just going to add 1 to it, right? Printf your name, your new name is %s. So my new name is this. Why? Because it took it added 1 to every single character, and h plus 1 is I plus 1 is j, and you get the idea, right? So this is the index access, or the index address access, which we saw in the last program. Now what happens if instead of providing this, we provide this? Let's suppose somehow you forgot to write the size, and you think, well, what the size is 100 in the name, as the size is 100 of the character array, and you provide 100. So what happens is it will add 1 to every single element of the array, and let's see what happens, right? And this is something you really would not want to do. And we see besides the 8 characters, we have some more characters, and things are changing. You see this thing. So this was different, this was again different, and this was again different. The reason being, this array, this in char name 100, is what this says is, let me tell you this. So when you say array 100, and it is a character array, so it saves 100 bytes on stack, but those 100 bytes are not zeroed out. So they are random data which is dependent on the program stack, state, or whatever. So it will depends on many scenarios, and essentially it is random for us. For all intents and purposes, it is kind of random, and this is what we call junk data, because we don't know what it is and we do not care what it is. It is essentially junk for us. Now this is what you can do is, instead of initialization, to get away from this, or to not have junk, what you can do is, instead of just doing this, we can assign every single element to 0. And what we can do is, how we can do is, we can do this. So this is one method of array initialization. And what this will do is, it will set every single element of the array to null. But I believe this is again going to get some problems. Yeah. Okay, now things are a little bit easier and more predictable. But again, now talking about the array initialization part, so either you can do this thing as we did in our arrays.c program, right? So we assigned a value every single time. Or if your array is, or I mean, the second approach, this is the first approach. Second approach is at the time of defining or declaring at the time of declaring the array, for example, let's say data type array as 2 or whatever, you can define value and value. And of course, this value would be of the same data type as that of array, because array holds the values of same data type. Now, we did not use this indexing method or this not this assignment method in this array.c file, because we cannot initialize 10, 100 or 200 elements until unless we really need those specific values at that point, right? So we use this part. Now, this has an interesting property. Not the property, but kind of something like property, you can say that thing. And what that is, let's suppose the array is 1,000 bytes or 1,000 elements long, but you just set only 2 elements, 2, 3. So what this will do is this will effectively make array 0 equals to 2, array 1 equals to 3, and array 2 equals to 0 to all the way array 999 equals to 0. The specification says that if you are initializing array this way, so the number of elements you assign this way, they're going to be this way, and any number of remaining elements, because here we have assigned only 2 elements and there are 1,000 elements, so 998 elements are still remaining. Those will be by default assigned to 0. And in this case, we did the same thing. So we initialized the first element as 0, and we left other elements, which effectively sets the rest of 99 characters as 0 again. So this is zeroing out the array at the initialization time. And here we just add every single thing. Okay, but there is something that should not be here. And let's see GDB. This is my main. We have a lot of things which we see this as so this is the loop, this is the loop, kind of, yeah. After the printf, this is the loop which adds 1 to the each element, and this is where the addition happens. So it adds 1 to ex and then move ex edx, and then it takes the value, it converts the word to keyword, and then stuff. So this is how it looks like in terms of this. Now, one thing to note here is you see this, see these instructions. It is moving this many zeros. And if we come back to this, we have 100, and 100 divided by 4 would be 25. So, but these do not seem to be 25. 1, 2, 3, 4, 5. So it did not zero out every single memory. It just zeroed out some part of the array instead of the whole array. Okay, so that is one of the compiler parts. You cannot really force the compiler, or the compiler does not listen to you in most cases. Anyways, so coming back to the topic of the difference between strings and arrays. So this was the character array in question, right? To come back to the question of what is the difference between double quotation and a single quotation, or what is a string or what is not a string. Now, a character array is something which is a normal array of characters, which is, again, you can be like, and since each character is represented as a printable character between single quotation, This is a single byte. This is also single byte. This is also single byte. And to represent it as an array, we just sorry, this. So if we do this, now what this will do is this array will be a character array of 3 elements, and at this time, okay, so this thing is at this time. Another thing to note here is if you do not specify the size of the array but initialize it like I've done here, right? So what it does is the compiler counts how many variables are there or how many members or elements are there in the array, and then it automatically sets the size to it. So this is also one thing which is quite lazy in some cases, but yeah, it works. So this is an character array, but if we say the AVC, this is not a character array, right? Not a character array, because anything in double quotation means anything plus a null character at the end. So this has 3 elements, A, B, and C, but this has 4 elements, A, B, C, and a null. So this is a string which by default has a null character appended to it, but this is a character array. So that is the difference between an array and a string in C, or a character array and a string in C. And that is also the difference between single quotation, double quotation. Actually, single quotation can hold only a single character element or a single 8-bit value, but a double quotation essentially works as a collection of characters. So you can put as many number of characters inside it as much you want. So is that clear, or are there any questions related to this thing? I'm going to discuss now something about, so after this, I will be discussing about variable length arrays and dangers of incorrect array usage, or what care should we take while using arrays. So should we move ahead? Okay, in AVC, arrays 3 or 4. The double quotation means whatever there is plus a null character. So double quotation AVC is 4. The size is 4 bytes in memory. But the thing is, if you calculate it using string length, such as this, if you do strlen on AVC, this function, where it is, where is it? Yeah, here it is. So the string length function will report 3 characters, because when you're going to print it or when you're going to do any work on it, there are 3 characters, because the null just marks the end of the characters. So the memory occupied by this double quotation ABC representation is 4 bytes, but for all intents and purposes, the length and when you're working on it is 3 bytes. Okay, so moving ahead, we have variable length arrays. Now, variable length arrays is the point where, right, we just saw that if we want an array of 100 bytes or 100 elements or whatever number of elements, we just specify it here, 10, 100,000, 99, or whatever we want, right? Sometimes we do not know in advance how many elements do we need for the array, because let's suppose you give the users yes, that is a valid operation, and that is what we are going to discuss once we discuss the variable length arrays. Now, so here what we had was to discuss to calculate the average of 100 numbers which were generated randomly. Let's suppose you give the user the ability to tell how many numbers. So let's write another program which is here array true.c, average of n numbers, right? So now let's first ask the user printf enter the number of elements, int elements equals to 0. Scanf percent %u, let's just put percent %u, and elements. Now we take the input as the number of elements, and then let's just describe it that way. Let's see if we can do that, right? Because we know something. Int array elements. Ten, 20. Okay, so this is something we forgot to take in our consideration, which is we need to make it dynamic, and we also need to make it dynamic. Now compile it again, and let's suppose we have 12 elements. So there we go. Let's suppose we have 50 elements. 50 is a little too much, but again, we had 50 elements. So let's see what happens if we say 1000 elements, and apparently we also get the output of 1000 elements. And if you see, if we scroll up, yeah, okay, now you see these all have consecutive addresses, and even if we go any way further, we see a lot of things, right? So the addresses are consecutive. These are array. This is an array, so addresses are consecutive. So let's see what the question comes is, how many elements can it really handle? Because there is a limited space, right? So let's just see what happens is 20,000 elements, and it works fine on 20,000 elements. Let's see 200,000 elements, and it seems pretty fine. Let's just see. Okay, same. Let's see 2 million elements, and it is going. Let's see the CPU usage and everything. CPU usage is 50%, and memory is 1.4 GBs. Okay, so let's see if it crashed or not. It is working fine. Okay, so the question comes is, how much space does it have, right? Let's see how much space main has reserved. So object dump minus d minus j dot text minus intel array 2 grep main minus a20. Okay, so we do not have a lot of space because only 48 hex bytes are subtracted on the stack, but we might have some other things, right? So let's just see it in GDB. This is the call to random. This is something something. And I think we need to debug it how it has so much space right here, right? Now, let that be for now. So that was how we discuss or how we can use variable length arrays. It is of course not recommended because uh, at a certain point in time, the space must be coming from somewhere, and if it is on the stack has a limited space. So if you really need to use variable length space, for example, you need to ask the users how many elements do you want, right? So the best thing I would say is to use dynamic memory. You can use malloc to allocate memory for those number of elements. So instead of doing this, I would suggest what you would have is pointer to array as size of int into elements. If malloc returns null, that means there's no memory. So printf no memory for this many elements, right? And let's just return one, just exit the program. And if we have memory, let's just free the memory. So this is a good practice. Let's just GCC it again. And it works fine as expected. So we also discussed how to use variable length arrays. And the last thing that is to be discussed is dangers of arrays, right? Or dangers or bad practices, right? Now coming to the question of the chat. Yeah. Is there any function to how much memory size machine can handle before execution of out of memory array? Not really. Something I am not really aware of, and I don't think there exists a function which checks how much memory size machine can handle before. It depends on the machine and various things, to be honest, how the machine is going to handle things. Because last time when I was doing something, I was kind of just trying to see how much memory it can take and everything. After a certain point in time, the OS just killed my program. So it depends on OS and application, how it behaves. But there are no set functions or specifications that after this much or this function will take, I mean, you can take this much size on the stack. Now, coming to the question of what care should we take while using arrays, and at the same time, is array 3 is AVC, but accessing array 3 is a valid operation. Now, we see to access an element, let's say nth element, we have to use the indexing n minus 1, right? What happens is, the question is, what happens if you put, let's suppose your array size is 100. So you can access from 0 to 99. That is where your 100 elements are. But the question is, what happens if I try to access 100? So what is at that location? or 101, I would say, or basically any other value, right? Or even let's say -1, right? What happens? Now this is when the fundamental understanding of arrays comes into practice. I told you arrays work like this. Arrays work, we have a base address. Then let's suppose the base address is BA plus 4 in case of integer, then BA plus 8, that would be the third element, third element, BA plus 12, fourth element, BA plus 16 would be fifth element. Now, if you do BA plus, let's suppose the initial array was 4 elements in size, actually 5 elements in size, but you want to access array plus array 5, which is the sixth element. Now, indexing or array access works like this, which would be array 5 would be array 0 address, right? Address of array 0 plus 6, actually 5 into 4, which would be 20. So past 20. So 4, actually 4 plus 4 plus 4 plus 4 plus 4. So now this is the something is here. And now this something will be returned by this array 5. And this is perfectly valid. And as we discussed in the last session about the C philosophy, well, if you are trying to access an element which is out of index for an array, then you should know what you're doing. I mean, you should not be accessing it, but I mean, the formula is this, more or less, right? Actually, the formula is this base address plus size of type into index. So if we put 5 as the index, what we get is this BA plus 4 into 5, which is basically BA plus 20. And this star means dereference, basically take the value from this address. And this address is the address of something. So it will return something. Similarly, if instead of using the index 5, you use index 50. So just 4 into 50, that would be 80 here. And something, right? There must be something at that location. And you will, if you have some confusion, let's just suppose BA is 100. BA is 0. Let's just BA is 100. So the address of the first element or the 0th element of the array is 100. So array 0 is something at BA plus 4 into 0, which is basically value at 100. And therefore this would be value at BA 100 plus 80, 180. And of course there would be something residing at 180. Now, of course, it is not the value of, or it is not a member of your array, but it is definitely a valid address. Or I would say, as long as it is a valid address, it has something inside there, and therefore you will get access to that thing. So this is in some languages, for example, Python. I think Python does not have this ability, but let's see what Python does. So let's create a list. God. And equals to 1, 2, 3, 4. Right. So let's say L0 is 1, L1 is 2, L2 is 3. Yeah, L2 is 3 and L3 is 4. Now, what happens if I access L5? list index out of range, and we get an index error, or basically an exception. Java also gives you an array index out of bound exception, but C does not give you because it trusts you, basic idea, right? And therefore, if we are talking about this -1, it would again do something like this. So at the index -1, you would get 100 plus, okay, we need to take the value. So 100 plus 4 into -1, which would be 96. 100 minus 4, right? Which is 96. And as long as it is a valid memory location, you get the data from it. So basically, I would say, to put it into perspective, incorrect handling of index can give you, or you or your user, the ability to read or write out of bound, right? Which does not really seem that big of a deal, because if you have not been into Explore development, you might be thinking, okay, so what can you do at next, right? Reading something does not really sound too bad, or writing something or something does not seem too bad. But if you know what to read and where to write, you effectively control. So if you control index, you effectively control what to write and where to write in case of an out of bound write vulnerability, which is basically a triple W case. And you can understand, if you get the ability to write anything anywhere, you can overwrite return addresses, you can overwrite certain things, you can overwrite a cookie, you can overwrite local variables which can modify something else. You get the idea, right? So if you can possess this ability to, read and write out of bound, and the best thing is, if you control the index, you can read and write anything. Now, talking about out of bound read, or the ability to read anything from anywhere, of course that is not really as useful as out of bound write, but at the same time, okay, so let's see what out of bound write can give you: code execution directly, and out of bound read is usually used in bypassing ASLR, because if I can figure out that there is a value which can be used as an offset, and I can read that value at the runtime. So even if ASLR is active, so even if I would say ASLR is active, that value is going to get randomly changed. But if I can read that at runtime, I actually get the access to calculate offsets, and therefore bypass ASLR. So this is something which can happen if you do not handle the arrays properly. Another thing that I would say is problematic in this scenario is, let's go back to our original thing, right? So and actually, yeah. So going back to this thing, so this also has a vulnerability. This program also has a vulnerability, and to be honest, and if we do it this way, elements, or in some cases, what people do is, if you have been to college, or in your class, a program has been told that take an input from user, how many number of students they want to process, or how many number of elements they want to process, and then process those elements. So what you do is you define an array, which is usually 100 or 200 bytes, and then you take the elements, and then you process those things. Now, in this scenario, so first we are going to talk about the first scenario, right? Actually, yeah, okay, control Y. So first things first, we are talking about this scenario. You have an array of fixed size because you don't think that you or your user need to process more than 100 elements, and you're pretty sure that the user has less than 100, for example, 20 elements or 50 elements to process. So this code looks pretty much pretty simple, but the thing is, I control the elements. So what happens is, if I put 100 or 200, I can overwrite the remaining 100 from, I can, if I put elements equal to 200, well, I get access to the next 100 or next 400 bytes, next 100 integer elements, which are offset from this array address. And you can understand this is basically an out of bound write vulnerability. And of course, out of bound write is different from, I would say, an arbitrary write, but at the end of the day, if it is pretty close to an arbitrary write, pretty much the same thing, right? So this is a problem. And since another problem is the input is taking as an integer, which is a %d, and of course this is an integer, so but the index is not supposed to be negative. So another problem is, if the index is negative, I can access previous elements. I can actually, okay, so thinking about this code, I might not be able to access previous elements, but you get the idea, right? If you control the elements, or if you control the index, you can do pretty much most things in most cases. In this case, if I put -1 or -200, then I is not less than elements. Okay, and this is not true. Okay, and therefore the loop will not run, and we get something which is 0, and we just exit, right? So just leave this right now. So this is again problematic if you are using if you're using the number which is not supposed to be negative. You should be using an unsigned number. So the better part would be unsigned int and use a %u. So that is one of the I would say advices for secure coding. Now let's move back and let's see what happens in this scenario where we have dynamic allocation of memory. Now in this dynamic allocation, what we are the problem is, again, first, this is the problem, and this is the actual source of problem, to be honest. The integer data type of the elements and not an unsigned integer, because what happens is malloc takes an unsigned number. So this, if I put -1 here, it would get -1 into 4 and -4, and then that would be used as an unsigned integer. And an unsigned integer would be 2 raised to the power 32 minus 4, and it would be there. It would try to allocate that many bytes, and in some systems you might not have that much memory available. So you effectively control whether this part will be taken or this part will be taken just because of the number of elements. And that is this is because this category of issues is kind of known as signed unsigned issues, or type conversion issues, which is basically not the type conversion, which is it is just positive and negative kind of thing, right? Because if your function expects something or requires something as a positive number, you pass it a negative number, it will interpret it as a positive number, which we saw in the beginning of today's session, as well as yesterday, what happened when we subtracted, or when we added -10 on an unsigned character, right? So this can lead to different code paths, and those code paths will be chosen by the attacker. So to avoid this, toward these kind of problems, I would say, now let's see what happens if we, or how we can mitigate these things. First thing is change %d to %u, which is basically an unsigned number. Change the data type of it to unsigned because we know that index is never going to be a negative number. Okay, so let's suppose max 100 elements we need to process, right? Let's suppose. So what we can do is we can check if elements is less than 100, less than equal to 100. So do something, or let's just reverse the condition, right? If elements is greater than 100, so printf only 100 can be processed, right? And return 1, return 2, whatever. So this is how you can kind of make it more secure than before, because there are no issues about the signed unsigned problems. There is no issue about memory overflowing. There is no issue of controlling arbitrary read or write operations in this program, and this is more or less pretty secure at this point in time. So any questions? I think we are done, and there are no more questions now. So today again it got 1.5 hours and we have covered only half, but if we are going to cover the next part, it will again take at least 1.5 hours. So let's cover the functions in the next session, and in the next session from today itself I have wanted to just take only 1 hour or 1.5 hours, because 2 hours 3 hours is a little too much to handle for others, as well as it really takes too much time, and 1 to 1.5 hours is pretty much a good time to focus on things, right? So we will be covering functions in the next session. If there are any questions about the arrays or any other thing which we covered today, please ask, because we have covered what we planned kind of today, right? So we are going to cover functions in the next session, and I'm unmuting you in case you have any questions. Just a second. So how do I
Look, my camera on mute.
check it? Okay.
Okay, you guys can ask question now. No one have any questions?
Okay, seems like everybody understood things properly. So just pass them the feedback link.
Sure. So just sending the feedback link so you guys can fill it up. And do you have any code for today's class that you want to send with these people?
Yes, I will be sending these programs which I wrote today. So array2.c, and strings, as well as one.c.
Okay, so what I'm going to do is,
programs.
whoever's sending the feedbacks, I'm just using their email address and send the code directly.
Okay, great. So go ahead and fill the feedback form.
This will actually help us as well. So, so I'm just going to put it in everyone. So this is the form, and I'll putting this same form in our website as well. I'll update the same thing. Okay. So if you missed the conversation, this thing or anything, just fill up the form over there, and it will send you the emails directly. It won't be an issue then.
Okay, thank you everyone, and we'll meet tomorrow in the next session.
Yeah, just make sure you are just clicking on that as just scroll down from. Once you scroll down, Kanna. This one. Just make sure you're taking season 2, not anything else. Okay, if you click on multiples, it won't go. Like I'm just making a thing like automate on season 2 for the season 2 code. If you select all, you won't be getting anything at all. So that will be an issue. So that's all for today. If you guys like these sessions, make sure you are visiting us. You could join us on WhatsApp. Link is already shared. If it's not, ping us on website. We'll share all those stuff. You can follow up on YouTube. All those sessions are live, and the HD video or recorded sessions will be uploaded on separate channel. A link will be shared on our website as well. So you guys got any questions, feel free to write us and I'll help you out. Okay, so see you guys in the next session. Have a good time. Okay, bye. Bye everyone, and thank you for joining in.